Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. Okay, so in this video, we are going to continue our discussion on Chapter 8, Limits and Continuity, with a subtopic of 8.2, Lecture Part 3 out of 4, that we call the subtopic of asymptotes. Okay, so before we continue, let me explain what is asymptote. It's something like we call, okay, let's say this is an y and also x. Okay, asymptote is something we call a line. Okay, choose this one here. Okay, let's say this is the line. Okay, the line of x equal to -2, and also a line of x equal to 2. Okay, so now asymptote is something we call a line that the graph will get closer and closer, but it will never touch or even cut the line of this line of x equal to -2 and x equal to 2. So it's something we call, okay, like this one here. So it's just getting closer and closer. And also if graph approaching to 2 from the right side, okay, then it come out with this one here, moving up and getting closer and closer to the line. But this graph, the red one, will never touch the line of x equal to 2, the one with the black ink. It will never touch, or it will never cross the line of x equal to 2. Okay, so it's just like this one here now. Okay, the line. It will just getting closer and closer to the line, but it will never touch the line at all. So this, we call it as an vertical asymptote. And there is also a line, let's say, if the graph we call horizontal line, and then the graph is just getting closer to the line, then we call that one as an horizontal asymptote. Okay. So the objective in this, we are going to find the vertical and horizontal asymptote. Okay, so a line x equal to a is a vertical asymptote for the graph of y equal to fx if either limit x approach to a from the right side of the function fx equal to positive or negative infinity, or limit x approach to a from the left side of function fx equal to positive or negative infinity. Okay. The method directly simplify, factorize, and also multiply by the conjugate. And there is x equal to a is the vertical asymptote. Therefore, x equal to a is the vertical asymptote. Okay, now, fx equal to 1 over x, vertical asymptote. X cannot be equal to 0, yes, because 1 over 0 is undefined. So, automatically, this is your vertical asymptote. And at the same time, this is also your domain. The domain of R is all real numbers except for x equal to 0, or we write this one as an from negative infinity to 0 union 0 to positive infinity. Okay, vertical asymptote is the value of x that will make the function undefined or x equal to 0. So limit x approach to 0 from right side of 1 over f, 1 over x equal to infinity. Okay, x approaching to 0 from right side. Along this y-axis, okay, along this y-axis is where the value of x equal to 0. Okay, along this line of y-axis is where the value of x equal to 0. So when x approaching to 0 from right side, x approaching to 0 from right, and fx or y approaching to positive infinity, something like that. And then when x approaches to 0 from left side, 1 over x equal to negative infinity. Okay. Okay then. Therefore, x equal to 0 is the vertical asymptote. Okay. And then a line y equal to b is a horizontal asymptote for the graph of y equal to fx if either, okay, for this one here, limit fx where x approaching to negative infinity or x is getting smaller to negative, and the function of fx approaching to the line of y equal to b, or x limit x approaching to 0 approaching to positive infinity, or x is getting bigger with a positive value for the function of fx, and then the function or the line graph approaching to the line of y equal to b. So the method divide with the highest power of denominator limit of infinite in lecture 3, case number 1 or case number 2, you refer to that again. Therefore, y equal to b is the horizontal asymptote. So fx equal to 1 over x and x cannot be equal to 0. That is the domain. Okay. Okay, now, first one here, x approaching to positive infinity, 1 over x. It's just like 1 over 10 equal to 0.1. 1 over 100 equal to 0.01. 1 over 1000 equal to 0.001. So look at the pattern here, 0.1, 0.001, 0.0001, which I think that this is approaching to 0, right? So when x is getting bigger, x approaching to positive infinity, 10, 100, 1000, 10,000, 100,000, then we may continue on our own. So we can see the pattern is getting smaller and smaller, and we can just make a conclusion that is approaching to the line equal to y equal to 0. Okay. So x is getting bigger, approaching to positive infinity, then fx or y approaching to 0. And also here, x is getting smaller or negative infinity. So let's say 1 over negative 10, which is negative 0.1. 1 over negative 100 equal to negative 0.01. And 1 divided by negative 1000 equal to negative 0.00. 0.1, 0.01, 0.001, so on then. Okay, so this also, the pattern of this is also approaching to 0 from the left side. Okay, this also approaching to 0. This also approaching to 0. So then And when x approaching to negative infinity, when x is getting smaller to the negative side, and here, then fx approaching to 0. Thus, y equal to 0 is the horizontal asymptote. So let's see now. When we combine between the previous page of this, okay, when we combine between the explanation of this with the horizontal asymptote. Okay, let's combine both together with the horizontal and also vertical asymptote cases then. So let's see now. And again, this is the vertical asymptote at y-axis and also x, okay. Along this y-axis, x cannot be x equal to 0, so it means that the graph will never cut the line or even touch the line of y-axis. So when x approaching to 0 from right side, okay, approaching to 0 from right, fx approaching to positive infinity. Fx, we may also state this one as a y, fx equal to y. Okay. Okay, then when x approaching to negative 0 from the left side, when x approaching to 0 from the left side, then fx approaching to negative infinity. Then x approaching to positive infinity means that x is getting bigger and bigger. Okay, so then fx approaching to 0. Then x approaching to negative infinity, x is getting smaller with a negative value to the left side, then fx approaching to 0. Okay, let's see now. So that's it. So this is the graph of fx equal to 1 over x. That's what we call separate graph, one a reciprocal, or we call a curve on the left side, and also the other side, one above and also one below. Okay, so this is the graph of y equal to 1 over x. Okay, so x equal to 0 is the vertical asymptote, and y equal to 0 is the horizontal asymptote. Okay, find the vertical and horizontal asymptotes of fx equal to 1 over x squared. Okay, so now for horizontal asymptote, x cannot be equal to 0 for this one here now. Okay, solution here. Okay, so fx equal to 1 over x squared. So for horizontal asymptote, okay, so then a limit of x approaching to negative infinity of the function of 1 over x squared. Okay, so guys, girls, when x approaching to negative infinity, okay, since that is a function of 1 over x squared, x approaching to negative infinity, so x, just imagine that the value of x is negative 10, negative 100, negative 1000, and just list, or write down any numbers that you think in your mind for negative value. When we have and x is negative, with a square here, everything becomes positive. So then it becomes 1 over infinity. Okay, so 1 over infinity, then it is equal to 0. Then limit x approaching to positive infinity of the function of 1 over x squared. Okay, And also when x is getting bigger and bigger, x equal to 10, 100, and 1000 whatsoever, so then the value of x p squared, they become positive. Okay, 1 over big positive value, it is just like 1 over infinity, then it is also approaching to 0. Okay. And then for vertical asymptote, okay, this one mostly we make a short form as an HA, horizontal asymptote, and vertical asymptote V dot A. Okay, so then the limit of x approaching to 0 from the right side, approaching to 0 from the right side, is for 1 over x squared. Okay, so when x approaching to 0 from the right side, something I call this is 0, so x approaching to 0 from the left, and x approaching to 0 from the right. Okay, so from 3 to 1, 0.5, 0.2, 0.1, 0.01, 0.001. So substitute inside into this value. Let's say x equal to 0.01 squared equal to 0.0001. Okay, 1 over 0.00001, then it gives you a big value which is positive infinity. Okay, you may just try substitute with 1 over 0.001. Okay, if I try by myself here, 1 divided by 0.001, then equal to 1000. So it's a big value, right? So we just name it as a positive infinity. Okay, and also for the limit of x approaching to 0 from the left side, 1 over x squared. So x equal to negative. From negative 2, negative 1, negative 0.5, negative 0.2, negative 0.1, negative 0.01001, negative 0.0001, you just name it. So when substitute into that x and then squared, it gives you a positive value, then you also come up with positive infinity. Okay, so now, okay, never mind. Okay, so now we call limit x approaching to negative and positive infinity, meaning that when x is getting smaller or x is getting bigger, is approaching to 0. So then the graph will sliding down, or might be from down here, approaching to the x-axis. Okay, and then for this one here, x approaching to 0 from the left and right, it gives you a positive infinity. So which I think that we are going to sketch the graph using a different colors here. Okay, so then 0 approaching to 0 and 0. So this is a line direction here. Okay, and then positive and positive infinity. So the graph will be something like this. Okay, and also here. Okay, so this is a graph of y equal to 1 over x squared. And as you see here, the domain is all the values of x and also all values of x, real numbers of x, except for x equal to 0. The horizontal asymptote is y equal to 0. Okay, the horizontal asymptote y equal to 0, and the vertical asymptote then x equal to 0. Okay, determine the asymptote of 1 fx equal to 1 over x squared plus 5x minus 6. Okay, so for this one here, x squared plus 5x minus 6, we can factorize this. Okay, you come out with x, for this one, 6 with 1 plus 5, 1 plus 6, okay, 1 with a 6 here, so minus 1 and x plus 6. Okay, we'll double check. X times x squared, x times 6, 6x, negative 1 times x, negative x, so 6x minus x, 5x, negative 1 times 6 equal to negative 6. Okay, so now, okay, so let's say if I come up with a line, okay, so according to this, before that, sorry. Okay, so then x equal to 1 and x equal to negative 6. So we got negative 6 here and 1. So when x approaching to negative 6 from left and approaching to negative 6 from right, when x approaching to 1 from left and x approaching to 1 from right side. Okay, so for this one here, fx equal to, from here we come up with 1 divided by x minus 1 and x plus 6. Okay, so from here also it tells us the domain of this f equal to negative infinity. The domain is all values of x except when x equal to 1, meaning 1 is not one of the domain of this function, union from 1, until negative 6. Okay, negative infinity until negative 6, union from negative 6 until 1, then union 1 to positive infinity. Okay, so now let's find out now where the limit x approaching to negative 6 from left side of this function, 1 divided by x minus 1 and x plus 6. And the limit x approaching to negative 6 from right, 1 divided by x minus 1 and x plus 6. Okay, it's just like, let's say, if I substitute the value of x, any value of x approaching to negative 6 from left, x approaching to negative 6 from left, if I choose, let's say here, negative 6.5. Okay, example. So now let's try now. 1 divided by negative 6.5 minus 1 equal to negative 7.5. Negative. Okay, we just put all that, we call the sign of negative there. And then, again, negative 6.5 approaching to x approaching to negative 6 from left. From left, negative 6.5. Negative 6.5 plus 6, negative 0.5. Okay, so negative multiplied with negative, you come up with positive value, right? And 1 divided by positive value equal to positive infinity. Okay. And then x approaching to negative 6 from right. x approaching to -6 here, approaching to -6 from right. Okay, I'll choose one value which is -5.5. Okay, let's try. -5.5. Okay, so 1 divided by -5.5 minus 1, -6.5. And -5.5 plus 6 equal to positive 0.5. So negative value multiplied with positive value equal to negative. And 1 divided by negative value, that will give you negative infinity. Okay. And then, same thing goes to with this one here. Limit x approaching to 1 from left of the function of 1 divided by x minus 1 and x plus 6. Okay, so x approaching to 1 from left. From left, let's say this is 1 and here is 0, let's say 0.5. Okay, then 1 divided by 0.5 minus 1. 0.5 minus 1 equal to negative 0.5. And then 0.5 plus 6 equal to positive 6.5. So negative multiplied with positive, negative, and 1 divided by negative equal to negative infinity. And for limit x approaching to 1 from the right side, 1 divided by x minus 1 and x plus 6. 1 divided by, okay, x approaching to 0 from the right side, from right. From 3 to 1.5, 1.2, 1.1, approaching to 0 from right. Let's say if I choose 1.5 here. So 1.5, okay, for x, 1.5 minus 1 equal to positive 0.5. And 1.5 plus 6 equal also positive 6.5. So positive multiplied with positive, positive, and 1 over positive value equal to positive infinity. Okay. Now, okay, so class, this is for vertical asymptote. For vertical asymptote. Then for horizontal asymptote, okay, horizontal asymptote, where the limit x approaching to, okay, so then it is 1 divided by x squared minus 5x minus 6. Is it? Okay, 5x plus 5x. Okay. Positive and negative infinity. We consider both. Okay, never mind. Because we have x squared here. So if I choose x equal to 10 or negative 10, even negative 10 squared equal to 100. 5 times negative 10 equal to negative 50 minus 6, negative 56. So 100 minus 56 is still a big value then. Okay, so if x is negative, so what about positive? So the value of course is getting bigger and bigger. So then we come up with a 1 over infinity, which is positive, that is approaching to 0. Okay, so then the horizontal asymptote is y equal to 0. Okay, so now Okay, I think that is not. There you go. Okay, so now x, let's sketch the line of the horizontal and vertical asymptote. And for this one here, sorry, where x equal to -6 and here is x equal to 1. X equal to 1. And then the horizontal asymptote is here, y equal to 0. Y equal to 0 means there is a line along this x-axis. Okay, this is the vertical asymptote and this is a line of horizontal asymptote. So let's sketch the graph now. Okay, let's say sketch with a purple line here. So when x approaching to 0, approaching to -6 from left, approaching to -6 from left, x approaching to -6 from left, then this come up with positive infinity. There you go. And then when x approaching to -6 from right, okay, it gives us negative infinity. Okay, that's it. What about x approaching to 1 from left side? So give it negative infinity. Negative infinity means that is sliding down again. Okay, and then when x approaching to 1 from the right, positive infinity. Approaching to 1 from right, then the graph moving up. There you go. Okay, so this is the graph of 1 over x squared plus 5x minus 6. Approaching to -6 from left, approaching to -6 from right, approaching to -1 from left, and approaching to approaching to 1. Sorry. Okay. And approaching to, okay, for this one here, approaching to 1 from right. So graph approaching to positive infinity. Okay. Now determine the asymptote of fx equal to 1x minus 1 divided by x squared, then x minus 1 divided by x squared minus 1. So in this case, we come up with x minus 1 divided by x squared minus 1. We may factorize as an x minus 1 and x plus 1. It's just like we can just simply cancel between these two and come up with 1 over x plus 1. Am I right? Okay. Now let's say that we call the function of this fx equal to 1 over, x minus 1 divided by, x minus 1 divided by x squared minus 1, and it is just like x minus 1 divided by x minus 1 and x plus 1. Okay, So we come up with a conclusion, and we call the domain of this function from x minus 1 and x plus 1 here, so means that x cannot be equal to plus minus 1. Okay. So for this one here, the domain of this function equal to negative infinity until negative 1, union negative 1 until 1, union 1 to positive infinity. Okay. Now, for vertical asymptote, where the limit of x approaching to negative 1 from the left side, and also limit x approaching to negative 1 from the right side. As I told you just now, we simplified this, the function of fx, into 1 over x plus 1. Okay, so we may just write down as a 1 over x plus 1 equal to, okay, so just imagine that when the value of x approaching to negative 1 from the left side is getting closer and closer, negative 1, the value of x which is close to negative 1, substitute here, and then plus 1 equal to, it's just like 1 over 0, and it gives us that negative infinity. Okay, and 1 over x plus 1, so when x approaching to negative 1 from right side, so just imagine that is the value of x approaching to negative 1 is getting closer and closer. We just imagine that negative 1 here, and negative 1 plus 1 equal to 1 over 0, then it also gives you positive infinity. Okay, negative 1 here approaching to negative 1 from the left, and approaching to negative 1 from right. Example that I can think of here, which is 0, negative 1, negative 1.1. Okay, so negative 1.1, negative 1.1 plus 1 equal to negative 0.1, approaching to 0, but it's negative then here. So 1 over negative value equal to negative infinity. And then, let's say I choose one value of negative 0.9. So now there's 0.9 very close to negative 1. So substitute here negative 0.9 plus 1 equal to 0.1. 1 over any value that very close to 0 but is positive. Okay, it's a positive and here, so 1 over positive value equal to positive infinity. Okay, now for the limit when x approaching to 1 from left, a function of 1 over x plus 1, and also limit of x approaching to 1 from right. Okay, approaching to 1 from the left side, and also approaching to 1 from the right side. Okay, I choose any value here from 0 to 1, let's say 0.9, and the value here which is 1.01. Okay, so now so the first one here, when x equal to approaching to 1, 0.9 very close to 1, and then plus 1, it gives us a positive of 1 over 2. And also here, let's say 0.01, 1.01 plus 1, which is approaching to 1 over 2. Okay, so there is a value here. It's not give us the sign of positive infinity or negative infinity. So for these two, we come up with a conclusion that x equal to 1 is not a vertical asymptote. Okay, so vertical asymptote is only for x equal to -1. Okay, now for horizontal asymptote, where the limit x approaching to infinity, x approaching to positive and negative infinity of x plus 1 divided by x plus 1 and x minus 1. Oh, sorry then. What is the question just now then? X minus 1, okay. X minus 1 and also x minus 1 here. Okay. So then, for this limit of x approaching to positive and negative infinity of 1 over x plus 1 equal to, for both of these approaching to 0. Okay, so then the horizontal asymptote is y equal to 0. Okay, so now class, for this case, let's imagine if x equal to positive negative 100. So 1 divided by 100 plus 1 equal to 1 divided by 101 equal to, okay, 1 divided by 1 equal to 9.900 times 10 power of negative 3. Okay, this is negative, okay, a 0.009009, which is, I think that is very close to 0, right? Okay, and also let's say x equal to negative 100, so 1 over negative 100 minus plus 1 equal to 1 divided by negative 99. Okay, so for 1 divided by negative 99 equal to negative 0.0101 and so on. And also it shows that it is very close to 0. So that's why for this both function, when x approaches the positive and negative infinity, we substitute into the value of x is negative, we call the positive value or very negative value is approaching to 0 or very close to 0. So horizontal asymptote equal to y equal to 0. Okay, now okay, and then okay, so then x equal to negative 1. Okay, x equal to negative 1. Okay, x equal to negative 1. Then according to the explanation just now, the graph will be something like this. Okay, and then because there's only one vertical asymptote of x equal to -1, x equal to 1 is not a vertical asymptote. So then there's only one here, vertical asymptote, and then horizontal asymptote is along the x-axis for y equal to 0. Okay, so then the graph sliding down at x equal to 1, then here. And there's a loophole when x equal to 1, there's a loophole, and then the graph approaching to x-axis. So this is the function of fx equal to 1 divided by x plus 1. I'd like to show you something. Okay, there's one website that can help us to find that we call the graph that we're looking for then. Okay, let's say y equal to x minus 1, okay, and divide by, x minus 1, and here is x squared minus 1. Okay. So look at this one here now. This is a graph. Okay, and graph did not touch the line of x equal to 1. The graph is moving up, approaching to the line of x equal to 1, and then the one here going to downside here, approaching to -1, but it never touched the line at all. Okay, so this is a graph of the one-on function, and here I missed to share with all of you, but I think that let me share with one of the graphs that we discussed just now. 1 divided by, okay, please refer to example 2. X, okay, 1 over x squared, then plus 5x minus 6. Okay, so let's take a look at this one here right now. So you can see here, okay, if I add up with this one here, x equal to -1, or no, x equal to -6, and also here x equal to 1. Okay, so x equal to -6 and x equal to 1 is considered as a vertical asymptote, which means that the graph will just only approaching to the line, but it will never touch or intersect the line at all. Okay, so I think that you may try the page by yourself. Okay, so now fx equal to 2 divided by square root of 2x squared minus 4. Okay, the whole function is defined except when the function inside is equal to negative, meaning fx is undefined if x squared minus 4 equal to less than 0. So opposite of that, to make the whole function of fx is defined, so to make the whole function of fx defined, then x squared minus 4 must greater than or at least equal to 0. And from here, come up with x minus 2 and x plus 2 greater than or equal to 0. Okay, so from here it tells us the domain of this function equal to negative infinity until negative 2. Okay, from negative 2 here, union 2 to positive infinity. So now, for vertical asymptote, where the limit of x approaching to 2, x approaching to negative 2 from left of the function 2 divided by square root of x minus 2 and x plus 2. Okay, so x approaching to negative 2 from left. Negative 2 from left, just imagine that negative 2 from left, from negative 4, negative 3, negative 2.5, negative 2.2, negative 2.1. Okay, so negative, let's say negative 2.1 minus 2 equal to negative, and negative 2.1 plus 2 equal to negative. So negative multiplied with negative equal to positive. Square root of positive equal to positive value, then 2 divided by positive equal to positive infinity. Okay, and then limit x approaching to 2 from right. 2 divided by square root of x minus 2 and x plus 2 equal to, x approaching to 2 from right. So from 4, 3, 2.5, 2.1, 2.01 and so on. So I choose 2.1. 2.1 minus 2 equal to 0.1, positive. 2.1 plus 2 equal to 4 point something. It's also positive. Positive multiplied with positive equal to positive value. Square root of positive is still a positive. Then 2 divided by positive equal to positive infinity. Okay. And then for horizontal asymptote, where the limit of x approaching to positive and negative infinity of the function 2 divided by 2 divided by square root of x minus 2 and x plus 2. Okay, let's say if I choose the value of positive infinity. Okay, let's say at positive infinity 1000, positive 1000. 1000 minus 2 equal to 998. 1000 plus 2 equal to 1002. So 998 positive multiplied with 1002 is also positive. Positive multiplied with positive, positive, big number. Square root of 1000's number is, let's say, hundreds, and 2 divided by hundreds number, 2 divided by big value is approaching to 0. And also, if I, let's say, come up with negative infinity, where x equal to negative 1000, negative 1000 minus 2 equal to, okay, let's say 2 divided by square root of negative 1000 minus 2 equal to negative 1002. And then negative 1000 plus 2 equal to negative 998. Negative multiplied with negative equal to positive. So 1002. 1002 multiplied with 998. Okay, it's a big number. So then 2 divided by 99996, for example, equal to, okay, it's a very small numbers because 2 divided by what a big number here is a positive, is approaching to 0. Okay, very close to 0. So now the horizontal asymptote. Okay, so this is only example here to represent this. So horizontal asymptote for this line is y equal to 0. So now let's sketch the graph. Okay, so we got negative 2 here and 2 here. Okay, so from this and this, and also the horizontal of asymptote, which is y equal to 0. Let's now sketch the graph of this, which is also here. Okay, by the way, class, do you realize that there is no graph in between negative 2 and 2, right? There is no graph in between here. Why? So simple. Okay, this is the function of fx, 2 divided by square root of x squared minus 4. Okay. So let's say if I choose a value of x equal to 1. So 1 square equal to 1. Okay, let's say x equal to 1 here. So 1 square equal to 1. And 1 minus 4 equal to 2 divided by square root of negative 3. So look at this one here now. Square root of negative. We are not talking about complex number, or even we are not talking about the imaginary part. We are only talking about the real part. So when we got here square root of negative, so the whole function is undefined. So that's why there is no graph in between here. Okay, so that's the graph of for the function of fx equal to 2 divided by square root of x squared minus 4. Now determine the asymptote of fx equal to ln x. Okay, so solution here for vertical asymptote, limit x approaching to infinity, approaching to 0 from the right side of the function natural log of x equal to negative infinity. And then where x equal to 0, where x equal to 0 is the vertical asymptote. And then for horizontal asymptote, no horizontal asymptote line. Okay, so let's sketch the graph of this. Okay, the line of y equal to ln x is the one here. Okay, we discussed the question of, we have discussed the line of y equal to ex and y equal to ln x in chapter 5. Yeah, x equal to 1, so then y equal to nx. So the domain of this function equal to from 0 to positive infinity, and the range of f equal to negative infinity to positive infinity. And determine the asymptote of fx equal to e to the power of negative x. Okay. So the solution here for vertical asymptote, there is no vertical asymptote line. Okay, and then for horizontal asymptote, limit x approaching to negative infinity of the function e power of negative infinity is just a symbol here. Okay, let's refresh. How's the graph of this function looks like? Okay, the graph of y equal to fx equal to e to the power of x. E to the power of x is something like this. So then e to the power of negative x from up here which is here equal to 1. So when x approaching to negative infinity, then the function fx approaching to positive infinity. Here, come up with e power of positive infinity equal to positive infinity. So then the horizontal asymptote of line and the limit of x approaching to 1 over e to the power of x equal to 1 divided by e to the power of infinity, which is equal to 0. Then the horizontal asymptote is y equal to 0. Okay, so you can see now the graph sliding down, approaching to the x-axis. So this is where the horizontal asymptote y equal to 0. Okay, conclusions, vertical asymptote. We may find a directly called the vertical asymptote using direct simplify, factorization, or multiply with the conjugate. And also the limit of this one here. Okay, positive value divided by 0, positive something equal to positive infinity. And if negative value divided by 0, come up with it from the negative side here. This one, just imagine that it's a negative 0.001. Approaching to 0 from the left side, negative 0.001. Okay, and then 0, and the positive value divided by 0 that coming from the left side. It's just like 3 divided by negative 0.01. Positive divided by negative, of course, give you negative infinity. And also negative divided by positive equal to negative infinity. So the conclusion here. So I do hope that this video will help you to continue the rest of the question in the lecture in the tutorial book. And that's all. Okay, this is all we call revision from the lecture of part 2. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. And till we meet again.